Morning, everyone. Can you see my screen?
Yes, I
Okay.
can see your screen.
Okay, then we start today's AX motion controller training. Okay. Uh, First here, you can I list down the AX series product, and I separate by the MA industry and the FA means factory automation. And first, we see the machine automation part. Like I separate our AX controller for the different part, and uh, in the left side you can see that the AX we have the X3C, AXC, X3, X5, and AX8 for the machine automation controller, and control the slave by EtherCAT, and can control servo driver, AC motor driver, and a remote I/O module, and the right extend the right extension I/O module. And you can see that for the remote I/O module, like we have the R1-EC, uh, R1-C, R2-EC, R3-C, AX5, and AS series RTU. And for the remote I/O module, I will introduce later for each module, the details. And here also have the AX5, the right extend the I/O module, and R3-C. And the left side is the right side is for the factory automation controller. Even our AX series, the definition is for the motion control, but some module actually it's just a logic controller. Means it doesn't support the ECAM or the synchronized function, so it cannot control the synchronous axis. So normally it just control the slave by mode pass or EIP. As you can see here, the remote I/O is like and the AS, the EIP communication module, and for the AC controller, and the robot and the vision. Uh, Maybe you can see here the picture I put here, like the AX8. Currently, we have the generation 1 and generation 2. Uh, Especially for generation 2, you can see from the appearance that the AX8 generation 2 compared with the generation 1, it uh, have more like a LAN port. For example, this module, it can support the full LAN port. This is very suitable for the uh, factory automation control because sometimes you need more LAN port to do the communication. So this kind of module is very suitable for this application. Okay, and during this introduction, if you have any questions, you can hands up, and then we can discuss. Okay, this page show the different level of our X controller. Like the entry level is AX3C, is the slim module, and the next is AXC, and advanced module is the AX3 and AX5. The high performance is AX8. Next, we go through the each module one by one from AX8 to the AX3C. The first one is AX8. You can see that from the picture here, AX8 support the SD card, and it also have also support the HDMI port, support the HDMI screen, and here has two LAN port, and can support the several protocol like Modbus TCP, socket, OPC UA server, and EIP, and also can be as the provenance slave. And it has four USB port. And here in the for the terminal part, you can see that it can support the IS-45, IS-422, or it can support the absolute encoder input. But for this function, you need to choose because these two functions share the same port. You cannot enable these two functions at the same time. And next, it support the increased encoder. And the built-in I/O is a high-speed ADI ADO, and you can uh, you can choose different DIDO mode like NPN or PNP. Here is the power input, and here is the EtherCAT master port. And here is the naming rules of AX8, and this the start. Here is the production name. Then next is the naming or control axis. It can support 16, 32, and the maximum is 64 axis. The E means the protocol is EtherCAT, and P0, the first digit, or is the like CPU type. P means Intel Celeron, 3 is Intel i3, and the third digital is 0 means the first version. Here MB1, you can see that the first digital M means the CODESYS soft motion, and we have three kind of type, and another one is soft motion CNC, means this one already built in the CNC license. You can use this directly, and another one is the CODESYS soft PLC only, means it's just actually this one just uh, you can think this one just as a normal PLC without the motion function. And the second digital is the B type means Windows. C type means Windows at the code says target visualization. Means you can use the code says built-in uh, visual function. And M means Linux, and E means Linux at the soft HMI. Soft HMI means the HMI is running based on the AX controller. Is you no need to use our Delta, the physical HMI to combine with the AX controller. And the third digital is one is first version, two is the second version for specific application. And the last one, T means NPN, P means PNP, is the IO type. And next is about the AX864, the specification. And you can see that here listed a lot of the features of AX8. And what I want to mention is that for the instruction for the cycle time, the minimum is 0.25 millisecond, and for the control axis means can synchronize within 1 millisecond. The maximum can support is 64 axis. Okay, and it also can support standard communication protocol, like I mentioned in the last page. And the peripheral hardware includes the high-speed local I/O encoder input, I-45 series, and it can support the remote module like R1-EC, R2-EC series. And here I list down the different module, the comparison. You can see like for the topology, uh, all the AX8 module is can can start the can support the start topology, and for the architecture and software, the left two is the Windows and the HMI app, and the middle two is the Linux and the HMI app, and the right two is Windows and the 3S app. 3S is the development company, means smart software solution, and the software name actually is CODESYS visualization. And here I listed the synchronized axis. You can see like from 16, 32, 40, 64. And for CNC function, some of them support, but some do not support, just based on the naming rules. And for the interpolation, or can support, and for the cam, gear, and a single axis function, all can support. And for OPC UA, it only can be as a servo, the communication. And for private net, these two don't support, and only the middle side, only the mid, the only these two module support the private net as slaver. Okay, here is the clear picture or generation 2A or the X2 generation 2 AX8 generation 2, and in the left side you can see that this one actually is looks like similar as the first generation, but the CPU increased a lot. This one is the Core i3, so actually this one the performance is very high, and it can support a lot of like neither the high speed calculation and the high accuracy control. And you can see like the generation 2 totally it have the three. The first one is the left side, and this is the AX8. This one also is generation 2, but it and the, and you can see here it support a 3 LAN port, but the build IO here it doesn't support the FPGA, means the field programmable gate array. So this just normal IO, and it don't support the high speed, and also it don't support the IS45, and don't support the encoder. And the right side here, uh, this keypad, you can use this to like do the to reset some fault or change the IP address or this LAN port. And you can see that here it supports a 4 LAN port, and the right side here it has the 2 EtherCAT port, and the built-in I/O is supported the FPGA, means it's the high speed I/O, and it also can support the increased encoder, absolute encoder, and this encoder also share with IS45 function, and it also can support the high speed counter. So why I list down here, because I want to let you know for the first generation, due to the lack of the raw material, so the first generation currently our factory already stopped producing. uh, in the future, what you can buy and use is generation 2, like the left side this one, and the right side these two. Okay, here is the naming rules of AX2, and you can see that the for different module, the controllable axis can support like from 12, 24, 64, and 128, and some module it can support the EtherCAT, and add the EtherCAT and can open. And for the hardware, means for the CPU, and some is the Intel Celeron series, some is the Core i3 series, And the second digital here, if one, it means the second version. For the software and firmware, actually is the naming rules is similar like the generation one. Some of them support the soft motion and add the CNC. Some just the soft PLC. Okay, and here I list down the generation two, three kind of module, and you can see the detailed here for the CPU, memory, and here the number of controllable axes. You can see that the maximum, some of them can support 180, 28, and the operation system always Linux system, which means for the generation two, we will not have the Windows type. We only have the Linux type. Okay, and the here for the communication EtherCAT, this one support two EtherCAT port. This one also support two, but the middle one only support one EtherCAT. The advantage of this one is like you can use the EtherCAT to control two communication loops. Okay. Okay, so for the communication protocol, the difference between the generation one and two is for the profinet communication. Currently, the generation two it can support the master and a slave, and for the OPC is same, just keep as a servo, and the EtherCAT port currently diff, two kind of this kind and this module can support two EtherCAT port and support two EtherCAT master port in parallel. And then it also have the built-in low voltage detection and a data override function for PAC. The function, the advantage of this function is when when detect the low voltage, it will stop write the flash and save the key data and safety shutdown. Just in case we'll write the wrong data to the address in the low voltage, and it also can support the local input and output and encoder input. But for the encoder input, currently only the AX3 AX8DH means this module. Okay, after AX8 is the naming rules of AX3, AX3C, and AX5. Here they combine together, and you can see that the product series defined by the first part, and for the controllable axis can support start from 8 axis to 64. Because here combined together doesn't mean each module can support the maximum 64. Later I will have a detailed for each module. For example, this one X3C, it only can support the maximum two kind, the 8 axis and 16 axis. And next is the communication protocol. It can support the standard EtherCAT and EtherCAT data motion light and EtherCAT can open. Like here, the AX5, you can see that it has four port. One is EtherCAT, one is EIP, one is for can open, and for the EtherCAT data motion light, why we have this module? Because if you see the module EL means the controller just support the DL motion control library, means it just can control the simple this module just for some simple application to control the um, to control the position axis or velocity axis. It cannot support the advanced motion function. It just control the axis to move to the fixed position or run with the constant speed. Like for the control mode is PP mode, is profile position mode, or PV mode, profile velocity mode. Okay, then next is about the hardware. Uh, Next is about the software and the firmware version. Here actually is for each, no matter for X3, see X3, X5, here is same, no different. And but all these three module, the feature is that it can support the local I/O expansion on the right side of the controller. Okay, then next is about the details of AX5 outlook, and you can see like here is a ICE45 ICE 232 the interface to connect here. Then here is the USB Type A. You can use the USB cable to to do the programming download. And here is the EtherCAT master port and the can open master port. And here is the two EtherCAT port. The supported protocol is similar. Here you need to notice that for the Profinet, X5 also can support the master and slave. And inside the cover, actually is the run and stop switch, and it also have another USB Type C, and also can support the SD card insert. And for the X5, it has a built-in 12 DI and a 4DO here. And here, this part is AX bus power. Here is I/O power, and the right side is the extension module. Later I will let you know because for X5, the the power cable wiring is a little bit different with other module because normally from our concept, the power supply maybe is from here or from the left side or from the bottom side. But for AX5, the wiring, the power wiring is connected to here to the terminal here. Okay, then here I just choose the AX5 16 the specification, and you can see like it can support the uh 20 Di 4DO and support IS45 232. Okay, and for this module, it can support the synchronized axis control, 16 axis within 1 millisecond, and here you can see that the right side expansion can only be used with the AX5 series module. Means even we have a lot of right side extension, but for AX5 it just can allow you to use the AX5 series module. But if you use the either CAT to communicate with the remote EtherCAT module, there will be no any limitation. You can use it with the R1-EC, R2-EC, or R3-C. Okay, next is the X5 different module comparison, and you can see that we have the 516, 33, 64E, and 64EL. Yeah, here is what I mentioned before. EL, it just support um, Delta motion control light library. And for the numbers of the real axis here, uh, 32 at 2, 64 at 2. Here the 32 means this number is for the total number for position axis and synchronous axis. Because I list down here for synchronous axis, this module it just supports the maximum is 16, right? But the total number include the position axis will be 32. And here this two means these two axes is controlled by pulse, not by communication, not by EtherCAT. So here is the same meaning. For example, this module 564E, the synchronized axis is 64, but but except the synchronized axis, it also have another capability to control the position axis. So the total is 128 at the two axes controlled by pulse. Okay, then the interpolation, cam gear, single function, and cam communication, all this support. And DIDO is same, OPCUA is same, and for Profinet, all support master and slave. Next is AX3, AX-3, the outlook. You can see that the power supply is in the left side, and also support the SD card run stop switch, and have the RTC battery. And here support the USB 2, and for the LAN port here it also can support the a lot of protocol. But for X3 for the Profinet it just support the slave. It do not support the master. And for the built-in I/O here, it also can support the IS-45 and absolute encoder, but like AX8, you need to choose the choose one of these two functions. Cannot use at the same time together. And it also can support the incremental encoder input, and for the high-speed DIDO and the EtherCAT master port. The feature of AX3, I just list down the 32 specification. Like this this one can support the synchronous axis control 32 axis within 1 millisecond, and this one from the picture actually you can see that it can can expand the right side module, and this one can combine with the our Delta AS series module, and it also can use with the remote module. The serial number, uh, the module name is R1 or R2-EC. Here I list down the X3 for different module and I do the comparison. Like I mentioned in the beginning, some of the AX3 module is just a normal logic PLC. Actually, it doesn't support the motion function. So, like list down here, the numbers of real axis, synchronous axis, and like gear, cam function, it all cannot support. In some application, you just use this as a normal PLC, but it can right extend the AS module. Okay, and start from here 308 to 364, and for the synchronized axis, the number listed down here, and the same definition for this one. For example, this means the maximum uh, slave the maximum axis this module can control. For synchronized axis is 16. For the position axis is 0. So the total is 16. And add 4 means controlled by pulse. Okay. The next module is AX-3C. We can see the appearance like this one is this is a same module. This one is very suitable for the compact cabinet. to save the space, and, the communication protocol. This one it can support the Modbus TCP, EIP, and here for the Profinet it support the master and slave. And the feature of AX3C is like it can support 8 axes or 16 axes within 1 millisecond. And here, this module also can write extend our Delta module, but it only allow you write extend R3-C. And it also can be used with the R1, R2-EC or R3-C, the remote module. And here is the two kind of X3-C for 8 axis and 16 axis. And here you need to know that for this module, because it's the slim mode, so it do not support the built-in DIDO. And for the OPC UA function, it do not for this one, the OPC UA, this module actually doesn't support, and it just support the for the Profinet, it support the master and slave. And for the AX, the next is AXC module, and you can see from the appearance, like here, actually is same as I introduced for other module. The difference is here, it has a built-in I/O, and this one it only can support the IS-45 communication, and you cannot choose. Means this one don't support the absolute encoder input. Means uh, you cannot choose the or you cannot connect the absolute encoder. This terminal only designed for the IS-45, and here it can support the incremental encoder input. For the built-in, it support 16 DI and 8 DO. Um, Here I list down, I choose the AXC12 and introduce the specification. Means this module can support the 12 axis synchronized with within 1 millisecond. And for this module, it just support the Profinet as a slaver, and it support OBC UA. And this one you can the peripheral hardware include a high-speed local I/O encoder input, IS-45 series, and it also can control up to 22 the remote module. Means this module it do not support the right side extension. Here is the compare of different module of XC, and here you need to notice is for CNC function, only this module support. And for the Profinet, it just support the as a slave. Later we go to the EtherCAT remote I/O, and you can see here like we have a lot of remote I/O series like R1-EC, R1-C, R2-EC, R3-C series, AX-5, and AS-RTU, and DVP RTU. Later I will introduce one by one and what's the difference and advantage of each series. And the first one is R1-EC. You can see from the picture, actually, this one, the size is, we define this R1-EC at the beginning as a slim module. So for each function is write extend, like DI, DO, AI, AO module, like this down here. This one is the communication bus adapter to communicate to do the data exchange with the AX CVPU, and it also can support the power for the right extend module. And you can see like for this R1-EC, here is the single axis pulse, and the MPG, the uh, handwheel input module, and the four channel analog input, and DO module, and a four channel analog output module. And the disadvantage of this series is if you want to use the analog input, for example, this four channel analog input, uh, in the software part, you only can choose one analog type. Means if you have the current type and the voltage type, and you want to connect to this module at the same time, but you cannot do the setting in the software. In the software, you only can set the same type for these four channel. Like if you set current type, then this four channel will all be current type. If you connect the voltage type here, it cannot detect. Next is R1-C series, and you can see from the picture here, and this is the coupler to supply power to the communication, and here is the I/O module. It can support 16 DO and 16 DI, and for the digital I/O, and the right side is analog I/O. The difference is here. You can see the power supply. Normally the power supply will be put here, means um, if the right side here, because normally for the coupler, it's the power input will have the top limitation. When you add the right side module, no matter DIDO or AIO, actually if the right side the power input is not enough, then you can add a power supply module in the middle. Then means this power supply module will provide the power for the here from for the right extend module starting from here, means you can extend a lot IO module without any without the power limitation. But for the R1-EC, you can see here this series it doesn't have the power module, so means when you do the right extend, it will have the power limitation, and you can when you add the uh, right side I/O module in our DIA Designer-AX software, in the hardware part, it will have like it will remind you if the right extend I/O module already exceed the power limitation. Okay, next is R1-EC series. For this series, it's very simple because it just supports the DIO. It doesn't support the AIO. And the feature of this module is like it doesn't support the write extend. It combines the coupler and the DIO together. Like this feature, uh, we have four kind. Like for R1-EC, this one support the 32 DI and a 32 DO, and this one is 16. This one is 32 input, and this one is 32 DO output. But you can use if the on-site DIDO exists, for example, 32, then you can use the EtherCAT to connect more R2-EC IO module. Next is R3-C series, and you can see here this is a the left side is a coupler to supply the power to the communication, and it also can support the right extend to connect with the I/O module, the DI, AIO, and it also can support the temperature module, and it have the power supply module. This one just like I mentioned in the R1-C. If the right extend the module have the power limitation, so you can add one power supply module to do the right extend to extend more I/O module. Okay, next is for AX-5 series, and you can see like for this coupler, and it can for this one it do not you cannot find the no, you can find the power terminal. Actually, it's not in the left side or the top side or the bottom side. Is you need to connect the power terminal. You need to connect the power to here, and it can support the mm, DIO, AIO temperature and the power. But for the power, the difference between AX5 and other module is you can see separate by unit power, IO power, and a power connection and a power connector. And you can see the picture here. This is the first IO power supply module, and this is the first group, the IO signal. And this is the second. Like I mentioned, for the X5, the power module is separated by the unit power module and the IO power module. And you can see that from left side, this is X5 CPU, the is CPU or the coupler. Then you need to connect the power to here to the terminal, right? Then here you will have the 24-volt input here. But for X5, we separate the uh, AX bus, the power and the IO power bus means for the yellow color, this one, the power is for communication, means do the data exchange between the coupler and the IO module. And the green part, the power is for the IO module, the IO terminal control. And you can see that the here the this module X dash 502 PS actually is a power supply module to do the right extend for the AX bus power. And this one, the green side here is the module is AX dash 510 PS 12. This one is the IO power supply module. So you can see that start from the left to the right side, the green color here to connect to combine together to like provide the to share the I/O power. And you need to uh, notice is that the like this one AX-516 16 PC30 means this one is I/O connection module 8 I/O voltage and I/O ground. Means this one is why we design this module because sometimes when you do the wiring, the power need the positive and negative. If you use if you add the module here, then for the I/O module, you can connect the grounding terminal to here. You don't need to connect the grounding or the positive voltage terminal to the starting to the to the left side because sometimes the distance between the module here and to the starting to the left side, the distance is long. Okay. Maybe here for the unit and I/O power module have a little bit confused. Um, Here is just a brief introduction. You can refer to the real AX5, the I/O module and refer to the operation manual to see the real wiring. Then it will be more clear. Okay, next is for AXRTU-EC. And this module, I think some of you already use this because the this is a typical our Delta AS remote module. The built-in module it support the 8 DI and 8DO. You can write extend a lot. The advantage of this the analog input module is it doesn't like the R1-C, the first module I introduced. Here, this module you can use the software to choose different analog signal type for different channel. You no need to it doesn't like R1-C. The software only allow you to choose the same analog signal for the four channel. Okay, for this module, like you need to notice that the total number of the module that can be connected is up to 32, and for some special module like the analog, temperature, or the load cell module can connect up to 16 units. The next one is the DVP series. This one is the cheapest our remote I/O module, and it also can write extend a lot of DVP series. The no matter DIO, AIO module or temperature or LoCO, and this kind of module. And you need to notice that for the right side of the RTU EtherCAT can be connected to a total 14 DVB-C, the series digital module, and the spatial module. And the feature and the advantage of this one is like if the remote I/O is disconnected from the master station, the user can choose the output value of the module is to keep the value before the disconnection or become zero. Okay, here do the I do a brief comparison of different remote I/O. Like for the DIO support, DOO support, AI R2-EC don't support, AO R2-EC don't support. For the pulse control, some of them support, MPG temperature load cell, some of them support. And here you need to notice that is the scalability for the R1-EC. That depend on the DC power supply, but it still will have the limitation because it don't because this series don't have the power module to do the write extend to support more write extend. And for R1-C, because it has a power module, so no limitation. And for R1-CC, because this module don't support the write extend, so this feature 0. And for the left, the R1-C and AX-5, because it also have the power module. So for the write extend, no limit. And for the RTC EtherCAT and ASRTU, one is 14 pieces, another one is 22 pieces. Okay, so till here is all the introduction about our AX CPU module and the remote I/O module. Not sure, do you have any question? Okay. Which PLC line have two separate IP layer for one network? Which filters for IoT? Two separate IP layer. So relation like Okay, if don't have more questions, then we go to the next part. Next part is about the real practice. Here I list down some tips for you to do the troubleshooting when you do the programming. And next part we will go to the software operation to let you see some when you do the real programming. If you don't know this part, maybe sometimes you will spend a lot of time to do the configuration. The first one is a lock function. In the lock here, sometimes when you encounter some error, then you can go to this page and to see like what happened. And for example, here the license file invalid means maybe you lack this license, or you need to update the license to the newest version. Next one is for the device repository, because sometimes if you use our Delta AX controller to connect the third-party servo or driver, then you need to import the EDS file or XML file. Then the step is you need to connect the tools, open the device repository, and to install the the XM file or EDS file. Then when you add the device or when you scan the device, then our AX controller can recognize it. Otherwise, it will not show. You cannot add to the control tree. And the next is library import. The method is to click here to double click the library manager, and you click install. For example, the DR AX8, the Linux, this is the library, because sometimes if our build side or if you want to use some instruction, if you but inside the AX controller it doesn't have the library, you cannot use that. So you have to use this method to install the corresponding library for the real then you can use the instruction inside in this library. After you insert the library, sometimes because for the hardware or the controller and the library, it will have the compatible issue. So you need to go to here the placeholder. For example, for the deer motion control, the arrow, the library, it have a lot of like from the old one to the newest one. Sometimes we just update to the newest library version. Another one is about the code upload, and this one doesn't like our ASPRC. When you download the program to ASPRC, you just click download and you can upload directly. But for X series PRC, if you do not download the source program, the source code, that means next time if another engineer want to upload the code, he cannot do that because you have to download the source code, not just download the running code. Here is the trace function. The trace I will show you later in the real software. This function is very useful because sometimes or after you finish the programming, you want to run it and you want to see the performance. So you can use this trace function to see uh, the real behavior or the real action or different instruction. And this one is about the simulation function. Because sometimes if you don't have the real servo, but you have a real case or project, then you can start to do the programming first, and you can use a simulation function just based on your laptop without any real AX controller or servo. This function can help you like do the debugging and do the pre-coding before the real project starting. Here is about how here is the method teach you how to claim the variable. Okay. Later we will do this part in the real software. And today the and today for the common function block, I list down here like mostly when you do the real project, this function block is a very common used function block. So today we will use this function block to do the practice and use the trace function to see the performance. Like MC power, homing, move velocity, move relative, move absolute, MC stop, MC reset, MC gear in, MC touch probe, and MC superimposed, MC read parameter, write parameter, MC cam table select, MC cam in, cam out. And this part is about the axis status. No matter here you can see the graph is down here. For example, from the arrow stop means the axis status will go to the disable. The notice tree here, the notice tree means that when you execute the MC reset and MC power equal false, then arrow stop will go to here. This direction is from arrow stop to disable, means you cannot from disable to arrow stop. This is one way, not two way. So sometimes if you jump, if you skip this way, for example, you uh, want to change the axis status from the arrow stop to the homing directly, you have to go to the standstill first. You cannot skip the standstill, then go to the homing directly. Otherwise, the program, the software will pop up the error to remind you the instruction, the sequence is not correct. Here, this part is very important. When you do the real programming, you have to follow up this, the axis state. Okay, then next we go to the real practice part. Here I just created the training demo, and I will use the stimulate function without the real X controller and to with combine with trace function like this one, the trace function to show you the master speed, master position, slave speed, and the slave position, and back to the program part. So I just want to show you like this is the entire programming. Later, finally, we were coding like this, and we will run this. And but later, but right now, we need to create a new project, and you can follow up my operation, and we do this step by step. So firstly, need to open the AX8, the 1.9. This is the newest version. Then we open this and create a new project. We choose the standard project. Click OK. Then here we'll go to the device module selection, and you can open this one. Then you can see that if you haven't updated to the newest version, like 1.9, if currently in your laptop is 1.8, means you cannot choose, for example, the newest module X3C. But you can see that because currently my software is the newest version, so I can choose the AX3C and the generation 2, the X8 module. Okay, so today we just choose the, let me see, the XC module and I do the practice. Mm, no matter which one you okay. Okay, if you also follow my operation and create a new project, after you finish this, and then we can take a rest, and we will continue the training 10 minutes later. No, we were back 10:20 Thailand time. Okay, we take a rest, and after you finish this part, and after we back to the training, then we will go to do the next coding, like claim the variable and use the common function block. Okay.
So mainly my idea is like we can make the storytelling. Okay, the previous issue before our system apply, and how we this data achieve it about this issue, how we this data solve it, and what is the impact benefit to the system. So I I I add main with this data programming. I focus on I focus on 10 points. I highlight that like this. So only one point I broadly explain. So how do you think? You will summarize, or I will need to summarize this one and need to put in your document that we shown before. Yeah. Okay. Maybe. Yeah. 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 Actually, I need to add some more information because this morning I discussed with Bentley and we will need to add some how to say some information also. So I need to add a little bit more information and then I can send to you. Right now, 10 page I think. Yeah, but you can summarize it because I just describe it for your team to understand what it is. So if you want me to summarize, okay, you can give me information with your maximum page. Like only half page, okay, I will summarize it. How do you think? How do you think? Yes. Yes, yes, yes. Yeah, yeah, he just reviewed. He want to add more information. That's all. Okay. So 10 page. Yes, it's okay. So maybe we can summarize only the main ones, like the main title, a little bit description, like this. But this one I just want to explain for your team what is our programming and what is the benefit. So you can summarize only one sentence is okay. Okay, and I will highlight the main point. Yeah. Yes, yes. Okay, 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 sure. I, I will highlight the main point also. Okay, in the paragraph. Okay, sure. Yes, sure. It's okay. It's okay. So I will send maybe this afternoon. Is this okay? Okay. Okay. Thank you, Glenn. Thank you. Thank you, thank you, Glenn.
Hello, and for your question, you ask which PLC line have the two separate IP layer, and normally you can check like when from here when you up after you selected the X controller module, then can go to the system setting here. Like normally for AX-C, because I choose AX-C, here it will show you the CLAM 1 port, CLAM 2 port. Here you can set the IP address by yourself for CLAM 1 and CLAM 2. If the after you choose some module, after you choose here, and when you go to the system setting here, it already show the CLAM 1, means you already even it has two port, but it shares the same IP address, so means that you cannot do the manually configuration to separate the for different IP domain. Okay, online. Then let's start to do the real programming. So before, normally for uh, for my how to say that behavior or my habit, I will like add the folder. The folder name is the variable. Then inside the variable, the folder, I will add the global variable list, or I will separate by bool, word, and function block. Okay, inside the function block, when you clear the when you want to use the function block, actually because I choose the language I use is the structure text, but some of you maybe you familiar with the later, so you can click this one to the tabular view. This one is a textual. This one is the textual view. You can add this one. This insert a variable, and you can click the data type. You can double click and click the input assistant. If you don't remember the function block name, you can click this, and you can search, for example, the basic MC power. Then it will pop up this. Then you just choose this one. The data type is MC power. Then you change the variable name because you already changed the variable name, so it will remind you like factoring, rename the variable. You just click yes. Okay. because later we will use the virtual axis master and slave to demonstrate. So here for MC power, we will need to claim two. One is for master, another is for slave. Here you just copy the variable name, change the variable name to 2. Okay, next we change we add another function block, MC velocity. We move velocity. This one, MC move velocity. Okay, next is for move absolute. MC. Okay, I already finished the function block claim. I will wait for 2 minutes. Then you can spend this time to finish the function block claim. Okay, then later we need to add the virtual axis. You can choose the soft motion general axis port and right click. Then you can add device. It will pop up here, and you can choose the virtual drive, add device, add one more master and slave. Okay. Then after you add the virtual X here, you need to rename it. Here you right click, go to the refactoring, rename the virtual axis. After you click, it will pop up this. The current name is this one. You need to change the new name. Same operation for the slave. Okay, after you add these two slave, then we go inside to see the detail or the servo configuration. Because this is a virtual axis, so maybe it will have some difference with the real axis. But later I will add a real axis and open the configuration to introduce you. We see currently for the virtual axis, you can see that the general setting include the axis type choose and limitation. Normally is the affinity, and another one is the modular, and normally we just choose the like for affinity. But if the application, if you can choose like this picture show here, if the transmission mechanism is by the ball screw, then you can choose this one. But it also can support another application like round table and build and the build poly. And then here have the number like 1, 2, 3, 4, right? And you can set the mechanism you can do the mechanism setting here. Like one is a command pulse per motor rotation. So normally here we set set 10,000 pulse for motor for one motor rotation. Because you choose if you choose a build poly, then here the four means is a diameter, right? If you choose a round table, then you can see that this is a movement distance per motor rotation. The one unit, the unit just depend on the real application. For example, if the real round rotate distance is 20 meter, then the unit is meter, then you can set 20 here. If the real distance is 20 centimeter, then if you set 20, then the unit will be centimeter. So the unit is based on the real application, it's not fixed. Okay, so maybe we just set 20. 20 means if the mechanism rotate one round, means the movement distance is 20 centimeter. Assume that we just assume that the real distance is 20 meter. And here 2 and 3 is the gear ratio. You can set here the gear ratio, the numerator and the denominator. We just set one and one. And but for the real application, you need to set this according to the gear ratio here. And here you also can select the position command. You can see that if you choose the reverse off, means for the position command. It's like running to this direction. If you give the negative command, it will the shaft here will run to this direction. You also can change to this one. The direction means for the positive command, the shaft rotate direction will be different. Okay. For the then next is for the slave. We do the same setting. Okay. And now I add a real servo to let you see the difference between the virtual and the real. The same operation, you click the EtherCAT communication, right? Normally, if you have the real, if you have the real AX controller, then the first step should be connect this controller. Then you should go to the communication setting, and you can click the scan network. Scan network, it will first you need to change your LAN port IP address to let it in the same I in the same domain with the controller IP. Then you can click the scan network. If the setting is correct, then here should pop up the AX controller, the module number. Then you click this one, and here will show the correct module. Because currently, this time we just use the stimulation to do the practice. So maybe you can try with a real AX controller. So, but this time we use the stimulation. So that's why when I click this one, it will not show anything here. Then after you connect to the real X controller, then you go to here for the EtherCAT communication. The normal operation, if you connect with the real X controller, you can click this scan for device. Because currently I didn't connect with any real X controller, so it shows no gateway selection. If you connect the real, it will scan for the real slave. If you, for example, you connect the two servo, then here will pop up the servo module here, the name, and you can click the auto merge to let the X controller to merge these two slave to the right side. So because currently I cannot scan, so I just manually add. You all definitely because like what I say before the real project, if you don't have the real equipment, I mean the real X controller or servo controller, you can manually add by here. Do the like preparation before the real project start. So here you can see that when you manually add the device, right, it will have the different type. Here has the AC motor drive, digital I/O module, servo drive, and a system coupler. So you can see that for the AC motor drive, when you unfolder, you can see that uh, we support the Delta soft motion light, the position arm. So here, the final three word is DML, is Delta motion light. Means no, if you add this kind of real axis, actually it doesn't support the motion function. This one just do the positioning control, means P2P mode or PV mode. Okay. This is the velocity axis. You can see compare with positioning. Here we support a MS and a MH. Okay, so including the multi-drive and the single drive here. And okay, this for digital I/O. You can see that for the AXC, currently it can support the R2-EC, the the digital I/O. This module is the remote I/O. Normally we add the servo driver because for the motion control, normally we combine the configuration should be AX controller with the servo. So servo will be here, the soft motion. And currently the common use the servo maybe A3-E or B3-E, right? So we just choose the B3-E. You click add a device, okay? Then you will see it will pop up here, and also you can rename the axis name for the to let it more easier to do the coding in the inside the motion program. Okay, so what I want to show you is just for the real axis, some configuration inside here. And you can see the general setting here, the EtherCAT address 1001. If you have more, it will automatically to assign the EtherCAT address. You no need to manually say this. And the next one is the COE parameter. And you can see that this actually is the startup parameter setting. And then you can click this one, and you also can choose all parameter. If you choose all parameter, it will show the PDO mapping all here. Normally we just set the startup parameter, and you can see like the operation mode 8 and the homing method 35. The homing acceleration means this kind of parameter is when the AX controller running, it will give this value at one time. Next is the process data, like the PDO, like RX PDO and TX PDO. The configuration here, you can see that the left side is a control word. For example, the index, the address is 6040, and the sub index is 00. And here also involve the target position, target velocity, target torque, and the touch probe function. And the right side is about the feedback, about the status word, the actual axis position, the actual velocity speed, the actual torque, and if you use the touch probe function, it will also have the feedback status or have the logging. Yeah, because here for the processing data, you already configure the control word, status word here. So when you go to here, it will show you the mm, the specified status of each word. You can unfold this and you can see the control word. Actually, it's combined. The control word is a word type, so it have the 16 bit. For different bit, it will have different meaning and function. And sometimes, if you want to, because this is a default configuration for the RX and TX video, if you want to delete or add some more address here, you need back to the general setting and you need to click the expert setting. Then it will pop up more options for the operator for the engineer to do the setting. So you can see here, when you open the expert setting, you can see that the expert process data. Just now, you can see that the default is the second. the prostate data here, you use the second ISPDO and the second TSPDO. So back to here, you can click this one, the second ISPDO, and you can see here, this is the default, the index and the address set here. You can, for example, you can insert, you can click insert to add the index you want to add in the IX video. Here involve a lot, like the servo parameter. We scroll down to see that here have a lot of other like talk and a homing method. Actually, this one already be configured in the starting parameter. And for example, the maximum acceleration, maximum deceleration. Okay. Normally, we no need to do the like delete uh, uh, or add other PDO here, but just in case, if in the future maybe you use some instruction, but that instruction need you to add some new address, some new PDO here, so you can open the expert setting and you do the configuration here. Okay. Then we go to the real servo configuration, and you can see that actually the configuration page is similar with the virtual axis, but still have a little bit different. In here, you can see that the servo gear ratio setting. When you click this, you can see that this one actually this is relevant with the servo parameter P1 P1-4 44 and P1-45. Which means if you sit here, uh, okay. If you say like this, it will automatically change the command per motor rotation. For example, if we set the 10,000 here and the unit numerator is we use the resolution or the encoder, then if you click OK, then after you download the program, because the AAX controller communicate with the servo by EtherCAT cable, so it will automatically to change the parameter inside the servo, the P1-44 and the P1-45. Okay. Here is the commissioning function. This page is only available in online configuration mode. And this one is the homing set. So here normally the mode 35 is depend on the current position. This is a simplest homing position, but you also can choose another type. When you choose, it will pop up here to explain you what's the dedicated signal you need to connect. And here you also can set the homing speed during search for switch, and homing switch during search for zippers, and the homing acceleration. So currently we just set back to the default. Here you can see the information of the servo. Okay, for like version, the name. Okay, but right now, because we will use uh, but, but later we will use the virtual axis to do the simulation. Okay, then we back to the motion program part. Just now we already finished the function block claim. So then we uh, just use the we need to use the instance of this function block in the motion program. Okay, so MC, maybe just now it's not clear. I show you one more time. MC, how to move this to here. And MC, power. Okay, uh, when I type the MC power 2, right, it will show the instance of the function block here. Then you just use the up and down button in your laptop to choose the MC power 2. After you choose this one, you need to double click the tab button in your laptop. Double click the tab button. Then it will pop up the input, output, or the function block instance. Okay. Normally for my behavior, like you say, you can see that for the MC power, it have the first one is you need to choose which axis, and the next one is enable, like execute the function block to power on the servo, and this one is a regular on, drive on. Here is the status output, and if the MC function block, the MC power, the function block is take effect. The BD here will output on signal. If the axis have some error, it will also show here. You can define a variable to get the signal to see what's the error code. Here is the error ID. Normally from my behavior, I will delete the because normally I no need to see to see this information. So I just delete the output to make it more to make the function block look like more uh, clear. Okay. So here for the axis, we want to control the master. So you just type master here, and it will show this one. Then you just use your mouse to click this to choose this one. Okay, be regulator on. So here we need to claim a variable. I mean, we need to claim a bool type, because this one is a bool type and it's on off. So we have two measure. The measure one is you just you just type power on one, right? Because we never claim this variable. You just type here, for example, the power on one is one for master. After you feel after you tap here, you just use your mouse to click the empty area, right click. Then it will pop up this auto declare. You can see that the variable scope is input, output, or is instant global. And normally you can choose to claim as a local variable or as a global variable. That's depend on you. But if you want to uh, use the variable in, for example, in another program, you need to claim as a global. If you just use the variable inside this program, for example, the program, then you can claim as a variable. Okay. So currently I define this as a global board, and the type is board, and the objection it will automatically map to the global or board. And here you can choose the type is the constant or retain or persistent. Okay, maybe some people or some guys when you uh, follow up my operation, it will not pop up this because you need to open the auto declare function. In the tools, we will have the options. When you open this, you need to go to find, you need to go to scroll down and see where. Here, general, text input, text editor, smart coding. Uh, here, you need to go to the smart coding and you need to enable this, like declare the unknown variables automatically. Uh, Maybe some guys, when you first use this software, this function don't enable as a default setting. So when you follow up my operation, you type power on one, and you right click the empty part, empty area, it will not automatically pop up the variable claim. So you need to open this. Click yes. Okay. Because the advantage of this, it can automatically to recognize the input variable type. For example, this is word, and this one, hmm, this this one actually is also word. But I just want to let you know that for the new learner, if you're not clear about the type of the variable, if you manually claim like in the here you don't know, uh, you are not clear, you should put the variable in in which area, like put in a board put in a board area or in a word area. But if you use the automatically can function, it will like help you uh, category category the corresponding variable. Okay, one. W power on 2. You see, this time it doesn't automatically pop up that. So maybe we try to change another name, power, same. Mhm. Okay, then we go, if it do not automatically clamp, then we go to here. We just copy and place, change this two. Then when you type power on, it can show here. You just choose this one. Okay. After after you finish these two steps, you can click the generate code, like do the compile to see the coding have any problem or not. Okay, after compile, it will show you the details. You can see that here, zero error, zero warning. Okay, then we can go to the next step. Next step, we need to MC move velocity. Master. Mm. For the velocity configuration, maybe you will feel a little bit confused. Like for the master, just now I configure here, and then you can see that the move distance per motor rotation 20. We just define the unit is centimeter, right? So the meaning is um, 1 second. The motor will cannot say the motor, should say the final mechanism. The move distance will be 1 second, 20 centimeter. Uh, uh, should be 20 centimeter per second. So when if follow up this definition, when you do the velocity set here, if you set 20, right, which means the final mechanism, the speed is 1 second, 20 centimeter. If you set 40 here, means uh, 1 second, 1 second, 40 centimeter. So actually the velocity is based on real, the real mechanism part here. It's not based on the motor speed. Okay. For the acceleration, normally we just set full 10 times all the velocity. Here the direction, you can choose set 1 or 0 to choose the running direction. Delete this. Okay. Move velocity master, then is MC stop master. execute. Deceleration is same as the move velocity. So here we set the deceleration 400, and here for the MC stop we set the same value. Okay, uh, I will wait for 2 minutes. Then you can follow up this and the program finish the program coding. Okay. Then next we just use the trace function to let you see the function of this function block. And here you can click the application and right click to add the object. You need to add trace, the trace for EtherCAT task because currently the programming we code under the EtherCAT task. So we choose this one. Add. Okay. Then you can click the configuration. Here allow you to enable trigger. If you choose this one, then means you can set up a bool or a variable to trigger to enable the trigger. And normally for the trace, we just use the default. Means it will always to do the tracing. So here we just add a variable. Variable here you can type master dot. If you click the dot, then it will show the features or it will show the sub sub variable or the axis. You can see here has a lot. But what we need to monitor is for example, if you type dot and we want to monitor the FACT, means the actual velocity. You can type FACT, then it will show this one. Then you right click, you left click, okay. Then it will add to the trace. You go add to another one, the master dot FACT PO. Just now we add the velocity. Currently we need to add the FACT, the actual position or master. Here you can choose different color to make it more obvious or to make it more clear to observe. Okay, here we add the or variable at the same time. We need to add the slave FACTV. Okay. Okay, you can see like for master and slave, we only need to monitor the running velocity and the running position. Okay, then you can move your mouse to this area and right click. Then you can choose move all variable to individual diagram because currently this for monitor uh, parameter currently in the one diagram. So when it's running, it's not obvious to what's the real status of this four parameter. So you should better click this move all variable to the individual diagram. Okay, then you can see that currently it's more clear. Like for the master, the velocity will be put in the first diagram. The master position will put in the second. Okay. Here, this time we use the simulation function to demonstrate, to practice. So you need to click the online and click the to open to enable the simulation function. After you choose this function, the simulation, here we'll have a red color to remind you. Currently, the program will running under the simulation. Okay, then later you need to log in to download the program. Okay, after you download, you can see that here you need to click this one to start the program. To start the program, here will become the color will become green. Okay, then we back to the program here. Okay, then you can see the default status of the master and the slave. Currently is you can see that when the program online, the status of the master is currently is power off. Also, the slave is power off. So later you need to choose this one. You double click this to change the status from false to true. But this one just like a set prepared menu, and this one double click. After you switch the prepared menu, then you need to click this one, write the menu, or you can use the quick button combination. It all it pop up here. You use the control as the F7 to write directly. Okay. After you enable this, you can see the master status change from power off to standstill, just like the slide the slide just like this page shows from power off to standstill. So currently the exit status go to here. Then next, if you want to like move velocity, MC move velocity, it will change from the standstill to here to continuous motion. Okay. Then next, we enable the move velocity. This we use the same operation to enable the to execute this function block. Okay. Currently, you can see it become true. Then we go to the trace function. Then double click. You right click to download the trace. Okay. Then you can see that the trace already start to monitor. Then you click the right value, subtrace. Okay. Then you can see like for the master, it start to run, and you can click the cursor. And when you move the cursor, you can see that the master first the first one is the master active velocity. This one is 40, just like what you said in the function block. It will run. It will always run within the speed 40 centimeter per second. And here the second one is the fact is a real position or the master. It will always increase, increase, increase. Okay. For the slave, because currently I haven't used any function block to running the slave. So for the slave is all the value is zero. Okay. Okay. Then we switch to offline mode. Okay. Then next. Oh, sorry. Just now I forgot to show you the. Yeah, sometimes if you find, for example, sometimes if you find the function block maybe stuck or in some error, you can in the in online mode you can click the online reset warm. If you click the reset warm, all the input will become to the default value. So we and you need to start the programming again. So right now and velocity. Okay. Then you need to download the trace again. Okay, you can see currently the master running, right? So just now because I forgot to enable this, so you can use the MC stop to stop the master. Right now I enable this. and I click stop trace. You can see that the master, the speed reduced to 0, and currently we can see the master status is stopping. So like the axis status show here. Why MC just now is change the axis status from the move velocity from the continuous motion to the stop status because I use this function block to let the master stop. Okay. Mm, okay. So here the important thing is if you always trigger this execute, it will like force the exit status in the stopping. Means you cannot do any other operation if you do not disable this function block. Okay, currently I disable this. Then you can see the master status here is from change from the power the stop change from stop to standstill. Then you can rerun the master. Otherwise, if you don't disable the MC stop, you cannot yeah means even you enable the move velocity this function block, it will not running. Okay. Then we try another is more absolute and more relative position master POS. Okay, I added the MC move absolute relative and gear in, gear out. Then later I add the MC, I use the eCam function. Before we use the eCam function, you need to click the application. You need to add the cam table, the operation like this. Right click the application, go to the add object, and add the cam table. You can name here, for example, cam1. Here it will pop up the master position and the slave position. And normally you can go to the cam table here, and you can see that it has the 1, 2, 3, 4, have the 4 point. Means here 1, 2, 3, 4, and you can use your mouse to drag the point to adjust the relationship, to adjust the position relationship between the master and the slave. Also, you can add by yourself, like if you click this one, add, you can see that here we'll add one more point here. You also can manually change the master position and the slave position here. And you can see that just now I changed 30, 30. Then the point will go or will change from here, from this point to this point. And later I show you 1.2, 1.2. And you can see that the 1, 2, 3, the second point, the third point go to here. But I want the speed will be same. So I need to change this. This is a segment type. It can support the line and poly 5. So if I choose line and I change this one, you can see that the means in this area the speed. Here you can see that in this area the speed, the old master and the slave will be same. So later let me see, like back to 0. You also can click this one to delete this point if you don't want this. Okay, so currently I just use the default 3, but what I change is here, the line. I change from the poly type to line type, because why I want to say this, because this similar to the simply the chasing share function. For example, the first period is for speed up to catch up the slave will speed up to catch up the master speed. Then in this area, you need to make sure the slave and the master move at the same speed. Okay, to do the sharing or do the cutting, and here when the cutting finish, then the slave need to speed down, need to reduce the speed to back to the starting position. So the cam I set the I configuration the cam routine like this. Okay, back to the here, and I use the MC cam table select. Here the cam table just use the cam table name cam1. Means when you choose the cam table select, if you have multi cam table, you can change the cam table name here. For this one, I didn't put this one in the global because normally if I run the cam table select in the motion program, I will not use this to in another program. So I just claim the local variable here. Period is one. If you set 0 means the slave only will follow up the master to running in one in one cycle. It will not always follow up the can table to continuously run. Here, the master absolute and the slave absolute, actually it have four kind of combination. Like if a master absolute 0 or 1, slave absolute 0 or 1. For this part, you can refer to the instruction manual to see the specific difference. For different application, you need to choose a different combination to meet the to meet the suitable to meet the real application. Currently, we just choose one and one. Because just now I deleted the cam table ID, so I do this one to set back the cam table ID here. Why I do like this? Because when you do when you enable the MC cam in, you need to input the cam table ID. This input actually is come from the here. The function or the purpose or the function of this cam table ID means, when you enable the MC cam table selection, the function block, it will based on the cam table here to generate a lot of point, because currently what you can see, what you set here is just 4 point, but actually inside the program, the MC cam table select, it will based on this curve to generate a lot of point. Then it will export like a data, data array, and it will output by the cam table ID. Then you need to uh, put the cam table ID to the MC cam in to let the slave follow up the master based on the data array. Okay, cam table ID. You can see that the auto de declare, it will recognize the type if the MC cam ID. So if you don't enable this function and you are not familiar with the variable type, then it will be difficult for you to claim the corresponding variable. Okay, then we copy this one, put here. The velocity difference, we just set OT, and then the acceleration, deceleration. Here is the tepid hysteresis, and the function of this one actually is, you can see in the cam table list, it also have the tepid and have the tepid table, right? The default, it will not use this, it will not enable this function, so you need to add this one, and you can see that in the tepid here. Actually, you can manually drag this one to here. The meaning of this is, you can see that this is a master position, start from 0 to 360, and the meaning of this one is when the master go through this position, like here, positive pass, negative pass, switch off. Actually here you can choose switch on. Then you can see here, like when the master go to this position, it can output a signal, because sometimes in the ECAM motion control, you need to like trigger the you need to get some signal when the master or the slave go to some position. So you can use this function to output a signal to trigger or enable the peripheral device to running together. But currently, we don't use this function. This function just let you know, for the MC cam in, we have this function, and you can change in the cam table. For this, we just delete first. MC cam in. Okay. Later is MC came out. Slave came out enable. Last one is superimpose. master. Oh, to slave. Okay, then we use trace to test the different function block. We download the program, log with download. Run this program. We power on first. Just now I show you the user move velocity, move stop. Then later I show you move how the performance or the move absolute and move relative. Okay, so download the trace. Currently you can see the master and the slave position is all at 0. So if I use the move relative first, and you need to give the master distance first. Currently master is in 0. So for example, I set 200, then write the value inside. Means if you enable the move relative, the master will run to the 200 position. Okay, if I enable this, then we can see the trace. Okay, you can see the master increase the speed, and okay, if you use a move relative, means it will run start from 0 to the 200. Okay, then we need to stop the master first because currently, sorry, no need to stop because if you use the uh, move relative, when it run to the target position, it will stop automatically. So later, so next we try to use the absolute. Also, we set the target position. This time we use the 500 and we enable this. And you can see it will start from 200, go to 500, then stop. Okay, okay, then we close this. Then next Next, I will need to show you the gear in and the gear out function. You can see that currently I set the gear ratio, the numerator and the denominator is 1 and 2. So right now I enable this gearing and I enable the move velocity of the master. Means you already gearing the master and the slave. The gear ratio is 1 and 2. Then if you let the master run with constant speed 40, then we can see what will happen. Then you can see that the slave speed only 20 centimeter per second because the gear ratio is only half of the master speed because the master speed is 40 and the gear ratio is 1 2. So you can see from the trace the master speed here is 40 centimeter per, per second and the slave is 20 centimeter per second. Okay, so here if you want to separate means jump the if you want to move the slave from the gear in, you need to use the gear out function. You just enable this, enable this. Okay, we continue to see the what will happen. Currently the speed of the slave is still 20 and the master is 40, and if you enable this, and you can see that the weird thing is the slave actually is not like reduced from 40 from 20 centimeter per second to 0 because the function of MC gear just let the slave and master uh, oh, just cut off the relationship between the master and the slave, but it will not let the slave reduce to 0 automatically. So if you want to stop this slave, you need to use the MC stop function to stop the slave again. Okay. So because I didn't use the MC stop for the slave. So currently, if I want to stop the slave, uh, I need to use the reset worm to stop it.
Some switching from the GI to the
Okay.
or
We serve on the master and the slave
the
again,
preview.
and later I show you
And then we
the
get back to
eCam function. Like the first one, you need to enable the cam table select to let the master and the slave can uh, refer to this cam table. Okay, then you need to click the you enable the MC camming function. Then okay, let us download the trace first. You can see that all come from 0 because just now I clicked the reset worm, all the position or velocity were back to 0. Okay, currently the master and slave, you can see the status. The status of master is standstill and the slave is synchronized motion. Means the slave already follow up the cam table and where later if you enable the master, if you run the master with the constant speed, then the slave will follow up based on the cam table we configuration. Okay, now we move velocity the master. Okay, let's see what will happen. Okay, we stop the trace, and you can see that the slave will run, and the slave speed is same as the cam table you set, like this one. Back to here. Oh, because here I said the periodical is 0, so which means you can see that in the slave only run one cycle, follow up the follow up the cam table, then later it will stop. I mean the speed will become 0. So okay, let me do this again, but I change to periodical. This one I change to 1 to let the slave can continuous follow up the master to do the e-cam running. Run this, power on first. Okay, then cam table select, enable, then cam in. Okay, then trace, download trace, then back to here, then move, let the master run. Okay, then let's see. You can see the slave will continuous follow up the cam table to run with the master. This is the speed, this is the position. So you can see the speed and the position actually is follow up the cam table to do the running. Okay. Then next I want to let you know that the superimpose function. This function block means sometimes if the slave follow up the master to run based on this routine, but sometimes if the slave have some offset, you want to do the compensation for the slave, then you can use the function. You can use the function block the superimpose to compensate some distance to adjust it. Okay, we can currently I set the distance 100, and you can enable this to let the slave to adjust to do some micro adjustment. Okay, we can start the trace, wait it run stable. Okay, then I enable this. Then let's see what will happen. What's the difference? Okay, you can see just now when I enable the superimpose for the slave here compared with this part, actually here should be the constant speed, but because you want to compensate the 100 distance, so the slave will need to add another need to add a additional speed, so the speed will increase to catch up the 100 distance. Okay. Okay, so this is all about the function block introduction. This is a common use for the real application. Mostly, the most time you just need to use the gear in, gear out, or sometimes you need to move the move absolute, move relative, and only when the slave need to follow up the master to do the cam eCam running, then you need to use the MC cam table, select MC cam in, cam out, and when the slave need to do some micro adjustment, then you need to use the move superimpose function. Actually, for this function block have more advanced configuration, and because this is basic training, so if you want to know more about this function block, actually you can refer to the instruction manual or the operation manual. Okay, okay. This is all about today's AX motion training. Not sure, do you have any questions? And after this training, I will share you the PowerPoint and the video recording of this whole training. Okay. If you don't have more any question, then we just wrap up the meeting. Okay. Thanks everyone. Bye bye.